Right. Let's come back and solve it. 2012 paper. What did they say? Draw the structure, draw the molecular structures of the following. Okay, as I said, the structures are compulsory asked in every paper. And so I've done this XCF6 structure in video number 52. And this structure, there is oxo acids of sulfur in video number 99. Done. Let's come back. Explain the following observations. NH3 and NF3 have dipole moments which are of opposite direction. A bit different question. It's easy to answer. Let's see. So they've given me NH3 and NF3. Okay, done. Fine. First, let us draw the structure. NH3. Okay, lone pair is already there. NF3. Okay, now what actually is a dipole moment? When you represent a dipole moment, how should the arrow be? The arrow should follow. How should this point be? When you ending the arrow, whichever is more electropositive, that arrow will go towards that. Okay, right here, just observe carefully. Whichever is what did I say? Yeah, more electropositive, that will go towards that arrow. Now in this case, we are going to see this electronegativity value. Yeah, so now what happens? Hydrogen is less electronegative than nitrogen. So the arrow just points this. Now in this case, when I have to see, the arrow points in this direction. Now see, this is more electronegative. Done. This is electropositive. Done. So the arrows are pointing towards in this direction, and here the arrows are pointing downwards. So just write down, this is more electronegative, hence it drags the electron density. This is more electropositive, so this goes down. Done. So because of this, the dipoles are opposite direction. That's why they have dipole moments which are of opposite direction. Done. The next question, all bonds of PCl5 are not equivalent. I did this in 2009 paper. And this question, sulfur in vapor state exhibits paramagnetism. I spoke in terms of antibonding orbitals in vapor phase. So I did that question in 2008 paper.